Hello, good morning, good afternoon, or good evening, depending on where you are. Welcome to the Message Broker version 8.NET integration session. My name is Matthew Golby-Kirk, and I'm the lead developer for the .NET support in the Message Broker product. So today we're going to cover a range of topics that take us through an overview of the .NET environment and how it fits into Broker. We're going to look at things like the Visual Studio integration, the development API that we provide, and how you integrate your applications together using the facilities we provide in the Message Broker version 8 product. So why .NET? So it's an interesting question, and it has a wide range of answers. Essentially, we have lots of clients that have a large investment in Microsoft and .NET technologies, things like Dynamics for CRM or ERP type applications. People use SharePoint for collaboration. They want to use Visual Studio for development of applications. And they, of course, use that Visual Studio to build lots of custom .NET applications, as well as many other third-party applications out there that integrate with the .NET space. And because .NET is a very popular programming environment for developers, it's important to be able to allow those developers to use Message Broker without them needing to relearn new skills. So if we look at the table at the bottom of this chart, we can see that for the 6 languages listed, we have a way to access that language using one of the compute type nodes in the Message Broker product. So you can access Java through the Java compute node, C and C++ through the C plugin nodes, PHP through the PHP compute node, and now with the version 8 product, you can access C# and VB through the .NET compute node. And the key there is, as I say, to allow developers to bring their own skills with them when they learn Message Broker without needing to relearn a different programming environment. Because with Message Broker, we don't want people to have to relearn a different skill set in a different language. We want them to be able to be quickly productive when they first come to use Message Broker. Okay, so here is a brief overview of the .NET framework environment. At the bottom, we have the operating system, so one of the Windows platforms, because the .NET support is for the Windows platform only. Above there, we have something called the Common Language Runtime, or we usually refer to as a CLR, and that is a virtual machine, very much like a Java virtual machine, that provides a set of libraries and classes and functionality to developers who write code that will run inside the CLR. So it provides services like threading support, garbage collection for memory management, exception handling, security, loading, profiling, debugging, etc., as well as JITting of code. And above there, we see the base class library in green. And the base class library is a wide and very functional set of library functions and classes that come with the .NET development environment to allow developers to be quickly productive and get going without having to write lots of common code over and over again. Above there in red, we see a various selection of boxes, and they are kind of individual technology-specific areas, things like ADO.NET for accessing databases, Dynamic Language Runtime for dynamic language support, WCF for web services, LINQ for language integrated query, and so on and so on. So technology-specific areas are encapsulated there. And then at the top, we have the Common Language Specification, which underpins the languages listed across the top, like C#, VB, S#, C++, CLI, etc. And what that Common Language Specification does is it allows those languages to work together and interoperate with each other and with the .NET environment as a whole. And we'll look at a little bit more of that in the next few slides. And then down the right-hand side, we have the Visual Studio tools, which, as you can see, link together all these different parts of the .NET environment and allow developers to gain access to them. So just a little bit more detail about the CLR. As I've said, it's an environment which provides a place for managed code to be executed, very similar to a Java JVM. And the CLR can be hosted inside of another process. So that gives that hosting process the ability to run managed code. And for example, SQL Server does this to run managed stored procedures. And as we'll look later on, we'll see how we've done that for Message Broker as well. And as I say, it provides all those key services to the code running inside it, loading, debugging, garbage collection, etc., etc. Now, moving back to the languages, to that common language specification, all .NET code is compiled from the source language into MSIL code, which is a bytecode environment, bytecode language, sorry. And using the common type system and the common language specification, it allows the languages to interoperate with each other in a very interesting way. So the CLI code is compiled into, excuse me, is compiled into an executable or a DLL, which is then built into an assembly. And that assembly is loaded by the CLR to be executed. And that code is jittered, just-in-time compiled, from that bytecode into the assembler language just before it's executed by the CLR itself. But the important point here is that at runtime, the CLR does not care what the source language was. Essentially, you can mix and match different languages together into the same DLL or across DLLs. So, for example, you can take a class in C# and subclass that in Visual Basic or vice versa. Or you can throw an exception in one language and catch it in a different language. So it's a very versatile environment, and it's a very nice way to provide cross-language support. So we're moving on now to integrating the .NET support with Message Broker itself. And as it says here, we provide extremely tight language-agnostic integration. So what does that mean? Well, it means that we've taken that CLR and we've hosted it inside the Message Broker itself. And we allow you to create your own compute nodes using Visual Studio itself to write your transformation logic and to host your .NET applications inside the message flow itself. This allows you to write your transformation logic and your .NET compute nodes in any of the CLR version 4 supported languages, such as the C#, VB, F#, etc., etc. And it's tightly integrated with Visual Studio because the Visual Studio is the development environment that you use to develop .NET compute nodes for Message Broker. And we provide plugins for the Visual Studio environment that you'll see as we move through what we've done with those plugins and how they work. We've also provided the ability for the .NET to be called, .NET methods to be called directly from our own ESQL language as well. So we've integrated it tightly there as well. And of course, because .NET has very good COM support, you can call existing COM applications from within your .NET compute node. And here we have an example of a message flow at the bottom that has a SOAP input node, followed by an ESQL compute node that might call out some .NET logic. A SOAP request node is next, and then, depending on whether it's a SOAP fault or a successful message that's returned, we have a .NET compute node to handle the response, and then it's wired to a SOAP reply node to send the response back to the originating client. And as you can see, that allows you to build a normal Message Broker message flow, but insert into that logic at any point in the flow, in the middle of the flow, the .NET support in any way that you see fit in that particular scenario that you're trying to cover. And of course, by hosting those CLRs inside the execution group, you would expect to be able to control that CLR operationally, and we provide that support as well. We give you fine-grained control through a configurable service of how each application domain is hosted inside of the CLR, and we're going to talk more about application domains later. And we also provide resource statistics so that you can see how much memory the individual application domains and how much memory your .NET applications are using inside of the Message Broker. So you've got control over the CLR environment as well, so you can see what's going on inside the CLR. It's not just a black box environment. Running .NET inside your enterprise. So, as I said at the beginning, the .NET support is provided on the Windows platform. And the Message Broker provides the .NET support on all the versions of Message Broker 8. So that's the Express edition, the Standard edition, and the Advanced edition. And because the Message Broker has a flexible connectivity options, you have two choices when you're using .NET inside your enterprise. We see two main sorts of customers here. We have customers that are completely .NET shops. They have .NET everywhere. They run Windows as their key operating system throughout their entire business. And in that case, it's quite straightforward. You can place .NET, do the message broker anywhere in that environment, and you can then use it to use the message broker to connect to all those different .NET applications in that particular scenario. Another scenario that we see used, though, is where a customer has either lots of different platforms or a different platform other than Windows that is their main connectivity platform. So they might be using AIX or ZOS or Solaris or Linux, and they have islands of .NET in different departments, for example, within that business. And they still want to connect those .NET sort of islands together, as it were. And you can use the message broker to do that. So you could use one of these smaller editions of message brokers, such as the Express edition, and install that on the Windows platform inside one of those islands. And then you can use the normal message broker connectivity options to connect that back into the rest of your infrastructure using either JNS or web service or MQ, etc., etc. So you can either be, if you're completely .NET, we just slot in very nicely, or if you've got a mixed environment, then you can install us next to the Windows applications as well as on the other platforms, and then connect them together using the normal message broker connectivity options. So looking at the .NET Compute node, the first thing we see is that it's a first-class transformation node, very similar to a Java Compute node that is already there inside the message broker environment. And as I've said, it allows you to build your transformations or write your transformations in any of the CLR languages such as VB, C#, etc. And to help you get started, we provide 3 templates, and that, as you'll see, they are implemented in Visual Studio. And there's a template to filter messages, modify messages, and to create new messages. So they're kind of the 3 basic patterns that we see people doing when they come to writing transformation logic. And there's a very simple method that they have to implement inside one of those classes in the templates, and we'll look at that as we come on in a few slides' time. And of course, inside the .NET Compute node, when you start writing the code, we provide you with full access to all of the message broker trees, such as the message itself, the local environment, the environment, the exception list, etc. And the node has a dynamic terminal support, which allows you to add as many output terminals on the node as you need. You get one by default, and you can add as many more as you like to support complex filtering scenarios. And as you can see, an example of the various things down the right-hand side, such as calling COM, invoking dynamics, changing Excel spreadsheets, inserting into CRM, etc., the kind of things that you can do with the .NET Compute node. So the .NET Compute node is quite simple to configure. You can just drag and drop it from the transformation palette, drawer in the palette, as you can see in this screenshot, onto the message broker flow canvas. And then you can select the node. As you can see here, the process request node has been selected, and the properties for that node appear at the bottom of the screen. There you've got on the basic tab, the ability to either browse or just drag and drop onto the node itself the DLL that represents the .NET code that you want to have executed that's been previously built. And you can just either, as I say, browse to choose assembly or drag and drop onto the node to configure it. To get into Visual Studio from the .NET Compute node, you can simply double-click on the node, which will launch Visual Studio, or you can right-click and choose Open Microsoft Visual Studio, as you can see there, which will open the Visual Studio environment for development purposes. And although it's not shown on this chart, on the left-hand side, on the basic, we have Advanced Validation. Below there's another tab called Visual Studio, and under there you can actually enter the name of a Visual Studio solution or project that will be launched when you launch Visual Studio from within the development environment for the flow. And why have we chosen Visual Studio? Well, Visual Studio is really the industry standard toolkit for .NET development. You can use any version of Visual Studio, from the free Express version right through to the Ultimate version. And it's, as I've said, very simple to launch Visual Studio from within the development environment for Message Broker just by double-clicking on it, and you can configure it to launch your solution automatically. And we've got that plugin that I've already mentioned for filtering, creating, or modifying messages. We're going to look at that on the next chart as well. And of course, as you would expect, Visual Studio has very good debugging support, and you can use that debugging support to debug the message broker, the code that you write when it's running inside of Message Broker. So here you can see what those templates look like inside Visual Studio 2010. You've got all that we've done here is go to File, New Project in Visual Studio. Up pops the New Project dialog box that we see here on this chart. And there you can see that on the left-hand side, we've chosen Visual C#. And under there, you can see there's a Message Broker category. And the 3 projects that are listed are highlighted there in the red circle to filter, create, or modify a message as it flows through the Message Broker. Once you select one of those templates and click OK, then the project will be created and the code will be filled in for you. And here you can see an example of a project that's been created. Now this is all the code on one screen. I've removed the comments to make it fit, so you can see essentially what that code looks like. You can see that we have a single class called filter node, and it derives from a base class that we provide, and that method called evaluate that you write. And in there you can see a region called user code where you fill in the code that you actually will do the logic of whatever this node is going to do. Out of the box, all 3 of the templates will compile. They are all built into just simple pass-through nodes that will just take the message that comes in and pass it through unchanged. You obviously have to fill in the logic, but out of the box, when you create one of those templates, those solutions will automatically compile once you hit the build in Visual Studio. And here, that same code has been enlarged to show what it looks like on the whole chart, just to make it a little bit clearer. You can see, again, the comments in the code have been removed, but you can see how we simply get hold of an output terminal and immediately inside the evaluate method. From the assembly that's passed in, we get hold of the message, and from the message, we get hold of the root element, which is the top of the tree. And then inside the user code, we would change or filter the message in this particular case and propagate it on to the output terminal that we chose at the beginning. It's a very straightforward, very simple programming paradigm that allows you to have very comprehensive access to the facilities that we provide in Message Broker, full access to all the facilities that the message trees have, etc. Other things that you can do when you're in the Visual Studio environment is use the object browser to look at the API that we provide. So Visual Studio comes with the ability to explore an assembly through the metadata that is included in that assembly. And the assembly that we ship with the Message Broker version 8 is the IBM Broker plugin assembly. And that provides access to all the facilities that you need to gain access to. And the projects that are built automatically have that assembly referenced. And you can see here that that assembly has been opened in the object browser. And on the left-hand side, you can see that underneath the IBM Broker plugin, there's a whole list of classes that are provided. And if you look at the scroll bar, you can see that that scroll bar is actually quite large, quite a long scroll bar there. And that means that you can see there's quite a lot of classes that we provide for you to use if you need to use them. So you can see it's quite a comprehensive collection of classes that provide access to a large range of the facilities of Message Broker. And then you can see that we've selected the NB element class, which has been opened in the top right-hand pane here. And you can see that we've selected the create last child method highlighted in blue there. And again, you can see that just for that one class, there's an awful lot of methods, judging by the size of that scroll bar, that can be selected from within that particular class. And then for that particular method, you can see that its signature at the bottom in the middle is visible for you to look at. And what's really nice about Visual Studio is that that signature will actually change based on the language of the project. So although we'd chosen C# previously, and it was a C# project, if you'd chosen Visual Basic, you would then see the Visual Basic signature, which looks slightly different. Or in Message Broker 8001, you've got a template for F# as well in the Visual Studio wizard, and there you could also see the signature of the method in the F# style, which again is slightly different as well. So it puts your developers quite nicely at ease in whatever language they're used to using. They see the signatures of the methods based on the way that that language will expect to see them. And of course, As well as the Visual Studio browsing of the API, we actually provide full API documentation as well on the Windows platform, and you can see that in the Start menu. When you open up the Start Programmed Message Broker version 8, you can see there's a .NET Programming APIs, which will launch this page that you see here. And here you can see down the left-hand side, we've got all those classes again that we provide. And on the right-hand side, you can see that one particular method in a particular class has been selected. And in this particular case, it's the add-bitstream method, and you can see all the parameters and the documentation for that particular API. And this API documentation follows the MSDN style, which means that you can choose the different representation of the signatures, such as a Visual Basic representation, Visual C++, or an F# representation of the particular API that you want to view. So again, you can view it in the format that's familiar to your developers. And of course, Visual Studio provides Content Assist for code that you write, and so as you would expect, you can see the Content Assist menu pop up here when I do control space after the root dot. And here you can see that the list of methods that have popped up, including extension methods that apply because the root is an NB element, and an NB element is derived from IEnumerable, or implements IEnumerable, I should say. And so you've got all the extension methods that you would expect there for link support, and you've got documentation for that particular method that's selected, telling you what the add after method will do. So just like any other .NET API, the IBM Broker plugin support that we provide has the full documentation right there inside Visual Studio when you come to use it, just like all of the other APIs that you might see. Moving on to debugging support. So, as I said earlier, you can use the Visual Studio debugger to debug your code. So you simply, from the debug menu, attach to the Dataflow engine process that is running your .NET Compute node. You can then put a breakpoint on any code any line of code, and then put a message through the flow, and then you will hit that breakpoint, assuming you go through that code path, and there you're stopping the debugger, and then you can do the normal debugging type things. So on this chart, if you look at the top right, you can see that on line 24, there's a breakpoint added on that line of code, and we've just hit that breakpoint and stopped at that point. So you can see that we stopped on a line that was looking at the output root element, and that line is highlighted in yellow. Moving on to the bottom right, you can see that under the call stack, you can see the code that called this particular method. You can see what processor we're attached to, moving to the processors view. And the top left, we can see that the locals view is there that you would expect to see as well. And there you can see that I've expanded the input message local variable that was declared on line 18 in the code. And underneath there, you can see that it has a root element, and I've expanded that. And then I've expanded the first child. And if you look second up from the bottom, you see that it has a name property called properties. And as anybody who has used Message Broker before will know that for a given message, the first child of root is almost always the properties folder, and you can see here how you can navigate the tree just by looking at the elements in the local variables view, and navigate the tree directly there in Visual Studio when you hit your breakpoint. So it's very good for developers to be quickly productive and to use their familiar debugging tools to help them understand what their code's doing and how that code works. And of course, you can look at any of the other local variables as well, etc. And all of the debugging support, like on different types of breakpoints, etc., breaking after a certain number of counts, etc. All those kind of things are supported as you would expect. It's a full Visual Studio debugging support is there for you. All you have to do is attach the debugger to the Dataflow engine process and set your breakpoints accordingly. I'm going to look briefly at some more of the facilities provided by the API that we've just had a brief look at so far. The API was designed to look and feel like a standard .NET API. By that I mean it follows the Microsoft Framework Design Guidelines, which is actually a rather large book that we took great detail to follow and to take account of its its guidance and guidelines where we almost everywhere that we possibly could. So, for example, it uses properties where appropriate, follows the expected naming conventions, etc. And again, the reason for doing that was simply to make it feel, make .NET developers feel at home when they come to use the message broker. We wanted them to have an API that was quick and easy for them to consume and follow the existing .NET practices so that they would be at home, so to speak, with that API once they started to use it. It's also designed to be used by as many different .NET languages as possible. So because of that cross-language support offered by the common language specification that we looked at right at the beginning, we took the decision to allow as many languages as the .NET 4 framework supports to be used with Message Broker. We didn't want to just tie ourselves to just C# or just Visual Basic, etc. We wanted to have the full support of as many languages as possible. So to do that, we've marked the plugin assembly as CLS compliant, and we follow the CLS guidelines where we can. So we have got some facilities, however, that are not CLS compliant, but following those guidelines, we have offered alternatives. So, for example, the C# language allows explicit cast from one data type to another to be used, but the F# language does not. So rather than go for the lowest common denominator, what we've done is we've implemented the explicit casts that can be used from within C#, but we've also implemented a series of methods that can be called from within the F# environment. So the support is available for both languages. It's just a different way of accessing it so that it feels more native to the particular language being used. Other facilities that are available in .NET that we took advantage of, things like scalar values and nullable value types are supported throughout the API. So all of the message broker data types in the message broker tree have the concept of null. So in the message broker tree, any data type can be null, which means that, of course, it may not have a value at all, and so we needed a good map from that to the .NET types, and the nullable data type was a perfect match for that. So it allows you to cast in C# an NB element directly to a nullable type that you expect it to be, and it will then perform that cast for you, and if it's null, the nullable type will just not have a value. And so, again, it provides just more richness in the API for the developers to take advantage of. Other things, we designed the API to be simple but powerful. So, for example, we provided lots of utility methods for performing common tasks, such as throwing exceptions and creating things like XML declarations. So, for example, creating an XML declaration, like we see here at the bottom of this chart, in other programming environments, that might be several lines of code to produce, but in the message broker for the XML and SC parser, it's a simple single method call there. You can pass the arguments in that you want to use, and that declaration will be created for you. So again, just trying to make it friendly and easy to use. So moving on to how we access the message broker tree. So this is the lowest level of access on this chart here. Each element in the tree has several properties. They have a parent, a first child, a last child, previous sibling, and a next sibling, which represent or point to the element in the tree to which that particular element we're looking at is connected. And you can access different elements in the tree by chaining these properties together. So, for example, given this message coming in, this XML message on the bottom left, it will build this tree on the middle right if you use the XML and SC parser. And to access the amount field, you would use like the code shown in the second bullet, root.lastchild.lastchild.lastchild, and if we follow that through, the last child of root is going to be the amount field if you follow that through on the tree view there. Now, of course, if that element, if that message didn't match and there was a last child missing, for example, if the tree wasn't as deep as you expected, then you can get a null reference exception out of that. So just be aware when you're navigating the tree using this syntax that you should really check to make sure that the messages are as you expect them to be before you just navigate around the tree. Another way to navigate around the tree, though, is by name. And here we are using the first line of code is the same as the one on the previous chart, the navigation to the root, to the amount element from the root. So you can see root x-c money amount, again, performs similar navigation to the same elements, given the same message and the same tree, but it's a much more obvious to a maintenance programmer coming along later as to what is the intention of the actual code there. You can see visually that it's expecting to navigate to the amount element underneath money, which is underneath the XML&SE parser. And so that gives you the ability to almost self-document the code in terms of what is expected by that particular navigation. And of course, XML has the ability to have namespaces as well, and you can use a string representing a namespace inside, if we look at the second bullet, to navigate via, including a namespace to navigate around the tree as well. You still have to be careful about null reference exceptions, of course. If there was no money element, then navigating to the amount without checking may give you a null reference exception, so you do need to be careful that the tree matches your input data or your expected syntax. But again, it's a nice way of navigating around the tree, almost self-documenting what the navigation is expecting to be. Now, this works for any of the message broker parsers, including the DSDL, Data Format and Description Language parser that we introduced in version 8 for non-XML data. So whatever the parser, you can use this syntax to navigate around that particular tree. And of course, with .NET having good support for COM applications, you can you can access a COM and other .NET applications directly from within your .NET Compute node. So here, for example, you can see how easy it is to call a WCF service. So WCF is the Windows Communications Foundation, and that allows you to call out to a web service that's hosted elsewhere. The thing about WCF is that it has a lot of different bindings. There's about 12 or so bindings at least. And only of those bindings, there's only a couple of those bindings that are actually interoperable with non-WCF clients. So what's interesting is that if you need to talk to a particular WCF service and you're a Java client, for example, then depending on what binding that service has been previously using, it may have to be changed to use a custom binding to be allowed access from say a Java or a PHP client if it's not using one of the interoperable bindings. If it was using, for example, a named pipe binding or a TCP binding or one of the other bindings, MSNQ binding, then it would need to be changed because there's no access to those bindings outside of a WCF environment. So what you can do, however, with the message broker is you can, with the .NET support, host a native WCF client directly inside the .NET Compute node, as you see in this code here. And that obviously allows you to use any of the supported WCF bindings because you'll be WCF at both ends. So this client, although we don't know what binding it's using just from looking at this code, we can see how easy it is to create a new client, set a method on it, and then to make the call, and using the data that came directly from the tree, so we're passing an NB customer element into, NB element of type named customer into this particular update service method, and then we're indexing to the name element underneath the customer, casting it explicitly to a string. That's that explicit casting we talked about earlier, and that data is then going to be passed to the client, through the WCF client to the service. And obviously this is a very simple WCF service here with a simple single method, but you get the idea here, is that could be as complex a client as you needed it to be, and it could also be using any of the WCF bindings over MSNQ or sockets or whatever. And so it's a very, very nice way to just bring your existing WCF or other .NET applications and use them inside of the .NET Compute node. And essentially, the only restrictions really, as long as you haven't, your client or .NET code doesn't have a GUI, because the message broker runs as a Windows service, then you can bring that code into the .NET 4 environment and then use that code directly from within the .NET Compute node. Another way to navigate the tree is using LINQ, or Language Integrated Query, as the abbreviation stands for. And this is a much more advanced syntax, really, or advanced way of navigation, but it should be fairly familiar to anyone who's any developer that's used to using the LINQ style of syntax. And just briefly to go through this chart, not to go into a lot of detail, but essentially the first line declares a local variable called x, that points to the top element of the tree that's shown in the bottom right of this code. And you can see bottom left, the style of message that comes in has 3 money elements, each of which has a currency, and 2 of those currencies are USD and 1 of them is GBP. So X points to the top of those 3 money elements, and then the middle line, the more complex line, declares a var list equals X dot where T equals arrow T dot name is equal to money, and cast a string T square brackets currency is equal to USD. So although that looks fairly complex, what it's actually doing is it's selecting all of the elements who have a name of money and also have a child element who has a string value of USD. And obviously looking at that particular message in that particular tree, that will match exactly 2 of those elements. And then the for each statement at the bottom of that code block will allow you to go through each of those elements that were returned from that link query. And so this shows, because the NB element, as I said earlier, implements IEnumerable, how you can use link to objects to just simply perform link queries over the tree in a very link natural way to, that your developer should be familiar with to gain access to the different elements within that particular tree. The other nice thing about the support that we provide in the API is the exception handling support. Now we've got a fairly shallow hierarchy of exceptions that can be thrown. The root of that hierarchy is an NB exception. There's an NB recoverable exception below that, and then a few other types underneath it, NB user exception, etc., etc. And when in your code, if you throw an exception, and that exception is thrown out of the node that you're writing your code within, back to the message broker, then the message broker will automatically catch that exception and turn it into a message broker exception and then throw it on up the flow. That allows you to catch that exception in any other message broker compute node. So you could have that exception caught, thrown in .NET, but caught in a ESQL compute node or a Java compute node higher up the flow if you need to do that. Or it can be caught using the try-catch nodes in message broker and wired off down the catch terminal, for example. Likewise, if you propagate your message from your .NET compute node downstream, the ability is there to catch exceptions that are thrown from nodes downstream of the .NET compute node and then be interpreted and inspected within code inside the .NET compute node. So there's this two-way exception handling that allows you to throw exceptions from within the .NET compute node back up to the main broker flow, or catch exceptions from down the flow and then inspect them and take action based upon what that inspection finds. And there's even the ability to create exceptions that can be caught directly inside ESQL, as I mentioned, that allows an ESQL handler to handle specific exceptions based on an SQL code and state. And as I said, those .NET exceptions are automatically turned into message broker exceptions when you throw them out of the node. Another facility that we have in Message Broker is the ability to have a pattern that generates you a web service that exposes a facade around a set of .NET methods. So this is a new pattern to provide a service facade around a Microsoft request response scenario. And what that allows you to do is you can drag and drop an assembly onto the Message Broker .NET pattern, and that will pop up a wizard that will allow you to introspect the contents of that assembly, and from there choose the methods that match the expected signatures, so public static methods, for example, with particular data types, and then those methods that you choose will then be allowed to be automatically turned into a set of code that will invoke those methods based on a particular input message, and that message will be expected to become in via a SOAP-based message, and it will automatically generate the WSDL that will expose the methods that you chose as a web service exposed to the Message Broker flow. So with just about 3 or 4 clicks, you can turn a .NET method and expose that as a web service that can be invoked from within Message Broker flow. The whole of the flow is generated through the pattern. So you can see here an example of the flow. The SOAP input node followed by starting the flow with the SOAP reply node at the end of the flow. The message will come in. It will automatically be validated. The ESQL compute node will be used to invoke that .NET method. take the response back, and then pass the reply back via the SOAP reply node. So it's a very sort of simple pattern-based approach for invoking a message broker service. And when you're calling from ESQL into .NET, as we saw the pattern do on the previous chart, there's a few extra syntax enhancements that we made to the ESQL language to allow the .NET methods to be invoked from ESQL. Things like the assembly name and the language of .NET, where you can choose what assembly what the methods will be in, etc. And you can even have this generated automatically by dragging and dropping an assembly onto a compute node to auto-generate the signatures for the .NET methods. But when it comes to actually invoking those methods at runtime, then you can see here on this chart, there's nothing specific or .NET specific about the method when you actually make the call. It just looks like any other ESQL method. So like ESQL could call into Java, it can now call into .NET methods as well. And there's a comprehensive type mapping between the broker types and the .NET types. And I've got a reference chart later on that just goes through what some of those types are. So briefly back to hosting the CLR inside the execution group. As I said earlier, we host that CLR in the execution group. And essentially the only restriction is that because it's a version 4 CLR, your .NET code must run inside a version 4 CLR. Now that doesn't mean it has to be recompiled at .NET 4 CLR. You can certainly run .NET 2 assemblies inside the .NET 4 CLR without any problem. As long as it will run the .NET 4 environment, it can then be hosted by Message Broker. And on the Windows platform, the CLR is automatically started when the execution group that hosts it starts. Now, it's not an error if it's not found, but no .NET code can be run without it. So when you install Message Broker 8 on the Windows platform, it will automatically install the .NET 4 framework. Now, you can choose to not install it if you wish, but by default, it will be installed, and then it will automatically be started every time the execution group starts, ready just in case any .NET code is needed to be deployed. Now, if there's no CLR in the box, as I said, that's not an error, perfectly fine. It just means that if you were to deploy a flow that contained .NET Compute Node or ESQL calling .NET, then you'll get an exception at deploy time. Now, the CLR, as I mentioned earlier, has all that resource statistics available to show you memory usage and garbage collection, etc., etc. Now, I mentioned application domains very briefly at the beginning. And an application domain is a container for scoping your code. So all code running inside the CLR will run inside an application domain. And by default, there's a couple of application domains created for every CLR process. There's a default application domain and a shared or a neutral domain. But above that, extra application domains can be created by user code. Now, the reason you want to create domains is so that you can isolate individual assemblies from each other. And it provides a point for reloading or sharing of code and data. So we can see in this example here, we have domain 1 and domain 2, and there's shared data in each. Now, they can be shared between the assemblies that are loaded into that domain. So the shared data in domain 1 is shared between assembly 1 and assembly 2. And the shared data in domain 2 is shared between assembly 1 and assembly 3. But they're not shared with each other. And this shows you that assembly 1, even though it's loaded into both domains, it's actually a separate copy of that DLL that's loaded. And it's any shared or static data is duplicated inside each domain. So it's a way of individually sharing the actual assemblies. Or you can choose to put them in the same domain, or you can choose to separate them. And when you unload a domain from a process, then all of the code in that domain goes away. As you can see here, that we've removed one of those domains, the domain 2, but the domain 1 with assembly 1 and assembly 2 in it is completely unaffected by that unloading. And in fact, in the .NET environment, you can't unload a single class or a single assembly. You can only unload an entire application domain as a whole unit. And so allowing sharing between the domains is by default not allowed. You can, of course, do things like remoting to share data between domains, but there's more work involved in doing it. And by default, you don't share state between the domains themselves. So this is sort of a textual version of what those diagrams were showing. The application domains provide the unit of scoping. An application domain also has several properties, such as a name. and a base directory where the code for that application domain lives, and an optional configuration file to provide any configuration for code running in that domain, such as any WCF binding information, etc., etc. And application domains are created by name. And in the message broker, if you don't give us a name, then we automatically will name or create a domain based on the application that that .NET Compute Node is deployed within. But you will always be in a domain that is named. It's just that the domain that is chosen for you is defaulted if you don't choose one explicitly. So you can choose to just default and have all of your code in the same domain within a given application, or you can choose to explicitly name an application domain, in which case the code loaded into that domain will be shared between the individual applications in that domain. So, as I've said, there's a message broker configurable service to allow you to set some of the more advanced properties of the application domains. And application domains also allow the ability to hot swap the code within them. I'm going to cover in a couple of charts' time. That's a way to speed up application development. And as I said at the beginning, there's statistics about the memory use that an application domain is making. And here's a diagram form showing how those application domains map to a message broker flow. In this particular example, there are two domains, one called ESQL that is used by the ESQL calling .NET flow, and the data loaded into that flow is not shared or accessible by default from the two .NET Compute nodes that are both sharing the .NET Flow domain. So you can see how we've chosen to separate those individual units of execution out. Of course, absolutely, they could be in the same domain, and they could have all been sharing the same code if you'd wanted to. It's just for this example purposes, we're showing them in different domains. And moving on to the hot swap that I mentioned earlier, and here we have something we call shadow copy, which is the ability to have the assemblies that are loaded into a domain copied to a temporary directory and loaded from there. Once you do that, and that's on by default, it then allows the application domain to be unloaded and reloaded simply by replacing the code on disk that the original assemblies were loaded from. So here's a build-up diagram that shows that in action. The first step is that you've got an assembly in Visual Studio, and you build that assembly, and that creates the assembly on disk that we can see at the bottom right here. And then you create a .NET Compute node, and you point that compute node at that particular assembly on disk. You then put a message through the flow, and you look at the output from the message. Maybe it takes a little bit too long. Maybe the output isn't quite what you expect. So you go and look at your code, you examine what's happened, and you can either use a debugger or you can just look at the code itself. And you see that you've made a small mistake, you want to change your code, so you just change the code and rebuild in Visual Studio. When you rebuild in Visual Studio, that changes the code on disk. It replaces the assembly that was there. And because the hotspot deploy facility was on, the .NET Compute node that was pointing at that assembly notices that the particular code has changed, and then you can simply put another message through, and you can then see that everything was fine, your code changes have taken effect, and there's no need to restart the execution group, no need to redeploy any of the code, and it's all taken care of automatically through the hot swap deploy process. And what that allows you to do is to give the developers that are developing the flow in the application development environment the ability to quickly make simple changes or even complex changes to the .NET Compute node code, and have those changes picked up as soon as they click rebuild in Visual Studio, and then have that the reloaded code automatically available for them to put messages through the flow and see the effect immediately. So that's a really nice way of not having to, as a productivity aid for developers, to allow them to speed up the application development environment. Now, beyond this though, once you move from application development to sort of a QA or a production environment, then you might want to turn off hot swap, and you might want to actually deploy the assemblies down onto the disk from within the message broker toolkit environment, just like you do with the other artifacts. And so we've provided the ability in the first fixed patch version 8.0.0.1 to have the assemblies for a particular application domain deployed down directly with the bar file onto the disk. Now that automatically turns off hot swap, so we see that being used in an application, in a test QA production scenario, whereas we see that not being used in the AD scenario because we expect developers to want to take advantage of the hot swap facility. But just briefly to wrap up, here's a chart that shows the data type mapping that I mentioned briefly earlier. I'm not going to go into this in any depth, but it's here as a reference chart that shows you the data types the mapping between the CLR types and the message broker types for the base CLR itself, and there's the same chart but rewritten for C# and again for Visual Basic. Now just a brief example here at the end before I finish. Here's just to show you how simple it can be to create a new account in Dynamics CRM. It's one of the things that you can do with the .NET Compute node. Here on the bottom left, we have a simple flow. An MQ message comes in. A .NET Compute node will take that message, and it will use the Dynamics SDK to make a call to Dynamics, taking the information from the message that came in, such as the account name and the phone number, which you can see in the bottom right. You can see the account name is Richard and there's a particular telephone number. And if you look at the top in the Dynamics Outlook view there, you can see that in this particular example there are no existing accounts. And then when we go to the next chart, we can see that after the .NET Compute node has been invoked, we can see a new account called with the name of Richard, and that particular phone number has been created, and the output message has been changed to show that the account was created successfully. I'm not going to go into the details of the .NET Compute node code behind that. Suffice to say, there's not really very much code required just to talk using the Dynamics SDK to create this particular account in this scenario. So just to show you, it's quite a straightforward process to create .NET Compute nodes that can access a wide variety of .NET applications and resources. So in summary, I've shown that Message Broker version 8 has very tight .NET integration. It hosts the version 4 CLR directly inside the execution group that allows the .NET code to be executed natively inside the broker, so that the code that's executing is literally right next to the Message Broker tree. There's no big hops required between the .NET code and the actual Message Broker code. There's very, very tight integration there at the lowest possible level. You can use any of the CLR languages to create your nodes, and we have integrated application domain support, as we've seen, that provides things like hot swap support. We have a very large API to provide access to the Message Broker facilities, things like navigation, element creation, and exception handling. We can go from .NET to an exception list, from an exception list back to a .NET exception, etc. And of course, we can catch exceptions thrown from .NET in ESQL as well. And we have very tight Visual Studio integration as well. You can launch Visual Studio from the Eclipse Toolkit development experience. We have plugins for Visual Studio to provide easy and simple node creation. And we also have the ability to provide Content Assist inside Visual Studio for easy access to the API. And as we've seen, we can use the debugging support that's built into Visual Studio to debug the nodes directly inside the Message Broker, running Message Broker in the execution group. So with that, that's all I had. I'm afraid, as this is a recording, there won't be any particular questions at this point in time, but I'm sure that if you have any particular questions, you can contact me directly via email, and my email address is mgk@uk.ibm.com. Just to repeat, it's mgk@uk.ibm.com. So I hope you enjoyed this presentation, and thank you very much for your time.